All right, welcome. 7.2, multiplying expressions containing exponents. All right, so here we're just going to be looking at examples where we have two bases that are the same. All right, so for example here, for this example we have two bases that have the same value, okay, but they have different exponents, and we're multiplying them together. All right, so we're going to start by expanding these expressions and see what we end up getting. So 6 to the third, well, that's just 6 times 6 times 6. And then we're going to multiply that by 6 to the fifth. So that would be 5 sixes. So 1, 2, 3, 4, 5. Okay? And then we can look at that and we say, well, how many sixes do we have? Well, that's 8. All right? So that would be the same as 6 to the 8. You plug that into your calculator, you'd end up getting some big honking number. Okay? But this is kind of the important part that we're looking at. But we still want to simplify it. So let's look at another example. If we did 4 to the 7th, well, that would be 7 fours. 1, 2, 3, 4, 5, 6, 7. And then we're going to multiply it by 4 to the second. So that would be another 4 times 4. Add those all together, we'd end up getting 4 to the 9, which is some other big number. Okay, again, this is kind of what we're looking at. Okay, but if you want to, again, you have to have the answer. Okay, so again, we have exponent, and we have bases that are the same. This would be our coefficient. Okay, because this exponent doesn't apply. It only applies to what's touching. So you could rewrite this as -1 times 12 to the 4th times 12 to the 4th. Okay? And if we were to expand that, we'd have -1, and then we'd do 12 times 12 times 12 times 12, and then we have 4 more. Okay? And how many 12s do we have? Well, we have 8. So we'd have -12 to the 8th, which here is another big number, okay? And on your test and stuff like that, they won't be that big, but either way, you could do it on your calculator and you'd be fine. Okay? Yeah, for these for sure you want to use your calculator. Okay, but we're trying to look at a relationship between when we multiply two base exponent pairs. Okay? When I talk about exponent base pairs or base exponent pairs, either way, this would be one pair, this would be one pair. And again, I told you, I think in the last class or in the last video, that the base and the exponent always stay together. Okay? All right, so here's another example. Here we're doing variables. That'd be a times a times a times a in this first expression, and then we're going to multiply it by a times a times a. Okay, so again, exponents is just telling us how many times we're multiplying the base by itself. Okay, add those together, or how many there are. There would be a to the 7. Okay, and we can't simplify any further than that. Okay, here's another example. Well, before we go any further, let's keep going. Okay, so we could rewrite this. These are all being multiplied. 5 times x squared times 2 times x to the 9th. Okay, order in multiplication doesn't matter. So if you wanted to, we could write the 5 in the front and then the 2, and then we'd have, from this one, we'd have 2 x's, and here we'd have 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are all being multiplied. Okay, so this is expanded form. All right, and then we would want to simplify. So 5 times 2 is 10, and then we have how many x's are we multiplying? We're multiplying 11, so we get x to the 11th power. Okay? And then here's one last problem. So we could reorder this as 3 times 7 times, usually I like to write my x's first, and then I do my y's. Okay? Yeah, but we wanted to expand those. Okay? So we'd end up getting 9 x's and then we'd have 2 y's. Okay? The thing is that we cannot combine our bases that are different. Okay? So here we'd still have, here we'd have 21, and then we'd have x to the 9th and y squared. So the exponents, because we can't combine those, so we just leave it like that. Okay? So here, looking at these, what is the relationship when we multiply like base pairs? Okay? All right, well, let's fill in some information for that. Okay? When you multiply terms with same base, okay, they have to have the same base. Like in this example, those didn't have the same base, so we can't do anything with those, okay? But if they do have the same base, you add exponents. Okay? So an example of this, okay, this is kind of like a generic version. X to the A times x to the b, so here they have the same base of x. What we do is we add their exponents, a plus b. Okay? So here's another example where we use numbers, something like a to the 5th times a to the 7th. Well, that's just a to the 3 plus 7, which is a to the 11th. Okay? So all the problems we did at the very beginning, we can do it a lot quicker by just adding those exponents. Another example would be something like 5m to the 3rd times 4m to the 7th. Okay? So 5 times 4, well, that's just 20. And then we do m to the 3rd plus 7. So we get, 20m to the secant to the 11th. Okay? And that's what you get. Sorry, I just had a colleague knock on the door. All right, so hopefully that makes sense. So again, if they have the same base, you can add, and they're being multiplied to each other, you add their exponents. Okay? So let's just do some other examples. All right, y squared times y to the 5th. If we expand that, that would be y times y. Okay, that would be our first value. And then our other one would be y times y times y 5 times. Okay? And then you'd end up getting y to the 2 plus 5, or y to the 7th. Okay? All right, here's another example. So last time we talked about negative exponents. Before we do any expanding, we need to take care of the negative. Okay, so maybe I'll write a little note here. Simplify negative exponents first. Okay, so here if we did that, remember if we have negative exponents, we bring it to the bottom and change its sign. So this is the same as x to the 6th over x to the 3rd. Okay, if you expand those, you'd get 6 x's on the top. And on the bottom, I'll zoom in a little bit for you, in case you're using an app or your phone or something like that. Okay, and then we'd have 3 x's on the bottom. Okay, if you're going to expand, like that, you can always cancel. Let me write that again a little better. You can cancel like terms. Okay, so in this situation, we have x's that we can cancel out that are on the top, and that ends up leaving us with x times x times x, which is just, well, maybe I read it over here, x to the third. Okay, so if you ever have something like that, you can cancel out variables like that. Okay, here's another example where we have a negative exponent. We need to simplify the negative exponent first, so that would give us x to the 6th over x to the 7th. Okay. Okay. Or actually, I think perhaps a better way to do this, that's the same way when we could do it like we did above. Another way to do that is if we have the same base, let me erase that really quick. Okay, so that's one way you can do it. Maybe I'll just do that again. So here we'd have x times x times x times x times x times x over x times x times x times x 7 times. Okay, and then we can cancel out x's that way. Okay, and all that leaves us with is 1 over x. So that's one way to do it. Another is, since we just barely talked about this rule, is that if you have the same base, we add their exponents. So here we have the same base, and these are being multiplied. We can write this as x to the negative 7 plus 6, which gives us x to the negative 1. And if we have negative exponents, we can bring it down to the bottom and change its sign. Okay, so those are two ways that you can do it when you're multiplying ones that have the same base, but then we have a negative exponent. Okay, so you can either simplify the negative exponents first, or you can just add their exponents together. Okay? All right, so over here that would just be 1 over x. Okay, here's another example. Okay, so first thing you'd want to do is perhaps to simplify, you could put the negative 2, and then you could have the 5. Okay, and then we'd have x to the 3rd plus 6. Okay, so here we're multiplying like bases. We add their exponents. So here we'd end up getting, I guess we read it over here, would get negative 10 x to the 9. Okay. Here's some other examples. Okay, very similar, except now we have two variables. We have x and we also have y. So if we want to, we can put these out in the front, which is what I like to do. Okay, so we'd have 3 times 5 times 4. And then maybe we could look at the x's. We have x, and then we have 3 x's here. I guess we could write it like this, x to the 1. If you're ever missing an exponent, it's always just going to be 1. So x to the 1, and then we have x to the 3rd. So we do x plus 3. Sorry, x to the 1 plus 3. And then we also have y's. So that would give us y to the 1 plus 5. Okay? And then we'd just multiply that stuff. 3 times 5 is 15 times 4 gives you 60. We'd have x to the 4th, because 1 plus 3 is 4. And then y is 6, because 1 plus 5 is 6. Okay? Here's some other, basically the same sort of stuff. Maybe take these numbers out in the front. That'd be negative 3 times 2 times 5. And then we'd have x to the negative 3 from here, and then we have a positive 1 right here, so plus 1. and then we have y to the 0, which is just 1. Okay? So we simplify that a little further. Negative 30, x to the negative 2, because of negative 3 plus 1 is negative 2. Okay? And y to the 0 is just 1. Okay? We wouldn't even need to write that down at all. Okay, but then we just need to simplify. The last thing is we need to simplify negative exponents. So here we still have the negative 30 at the top, but then we're going to bring the x to the negative 2 down and change its sign. Okay? All right. This is one thing that a lot of people, again, this 0 only applies to the x. Oftentimes people will write this whole thing down as 1. Okay, but remember the 5 is by itself. 5 times y to the 0. Okay? Let's do a couple others. These ones don't have parentheses, but it won't make much of a difference. Instead, we're having like a multiplication sign between them. So we can multiply the numbers first, so negative 8 times and negative 5. And then we're going to multiply it by, we'll do a to the negative 2. And we have another a, which is a positive 2, so we'd add those together. And then we have b to the third, and another b to the third, so we'd add those. Again, if they're multiplying, these are all being multiplied, then we add their exponents. Okay? So here we'd have negative 8 times a negative 5, well, that gives us a positive 40. We'd have a to the 0 and b to the 6. Okay, and we know that anything to the 0 is 1. So we'd have 40 b to the 6th, and that would be your answer there. Okay, so if you haven't already paused some stuff, I'd like you to try 8, 9, and 10 if you haven't yet. Okay, again, we have the numbers. We'd write those first. I mean, it really doesn't matter, but I think it makes it look nice and it works well. Okay, and then we could do our x's, x to the negative 2, and y to the negative 3. Okay, and the last thing you'd need to do is to take care of the negative exponents. Okay, so negative 4 times 6, I guess I didn't do that yet, that would give us a negative 24. And then the x to the negative 2 goes down and give us a x to the positive 2, and the same as the y. Okay? So we need to take these down and change their sign. Okay? Now we have some fractions, all right? Oftentimes you can just do that with a calculator. Here we'd have 2/3 times 1/5 times m to the negative 4 plus 3. So again, we have same bases. We add them, add their exponents. Okay? And then we just have an n by itself. Okay? So after that, probably want to simplify. When we're multiplying fractions, we multiply straight across. So that would be 2/15. Okay? We have m to the negative 1 from this. I didn't write that very well. And then we end up having an n still. Okay? The last thing we'd need to do is to bring it down and change its sign. So that gives us 2n over 15m. Right? And yeah, when you do problems like that, keep it as one fraction. Don't have it separated or anything like that. Okay? And then some examples of decimals. So here we'd have something like 0.7 times 1.8 times r to the 4th plus 0. And then we'd have t squared. All right. Plug it into your calculator to figure out what that is, that would give you 1.26 when you multiply these two. And then we'd have r to the 4th t squared. All right. Having a few last problems, okay? Here they want us to find the area, where the area has a variable, okay? But we know that when we're trying to calculate the area, it's just area is length times width, okay? Two-dimensional. This could be your length or width, and that could be your length or vice versa. It doesn't really matter. So A here is just what we multiply these together. So 4x squared by 7x to the 8th. Okay? Actually, don't even need those parentheses if you don't like those. Just do a multiplication sign like that. All right, and then we're just going to do the same thing we did before. So 4 times 7, and then we do times x squared, x to the 2 plus 8, and we'd get 28x to the 10. And that would be your area. Okay, volume. Volume is three-dimensional, and the equation for that is something like, well, I guess if it wasn't a cube has all three sides that are the same. So here it would just be and I'm just trying to rewrite this. So if it was just a regular, like a rectangular prism, then you do something like length times width times depth or something like that. But since it's a cube, all three sides are the same. So this would be 5y squared. This would be 5y squared. Okay? And to find the volume, we just multiply those together. Okay? So that would be like 5y squared. And we can square that. Or cube it, I mean, since they're all three the same. Okay, it's the same thing as y, or 5y squared, and we're multiplying all those together, okay? So if that makes more sense, we can just do it that way. Okay, and then we multiply, that's the same as 5 times 5 times 5, and then we'd have y to the 2 plus 2 plus 2, okay? And that just gives us 125, y to the 6th. Okay? And the last one is a word problem. Lerna's hydra is a mythological creature that appears in some stories, like Hercules, okay? Or at least it was on the movie, okay? It says here, such as the 12 tasks of Hercules. The hydra is a one-headed monster that has one head, okay? I think that's kind of redundant. But when you cut its head off, 2 more heads are born in its place. If a hero tries to conquer it by cutting off all of its heads every day, so if you cut off the heads once a day and you cut all of them off once a day, how many heads of the hydra would have on the 3rd day and the 10th day? All right, so the first day, let's say before he cut anything, so this would be day 0, okay, there would be 1 head. Day 2, he cut that off, and all that what would come back would have 2 heads, okay. Day 3, okay, you cut each of those off, and each of those 2 break into 2 more, so we'd have 2 times 2, okay? So it doubles every day. So day 3, or day 4, would have, or I skipped day 1, my bad. Okay? Gosh, I'm having a hard time with this. Okay, 2 times 2, okay? Day 3, he cuts all their heads off and they double again. Okay, so here we kind of see this pattern. This would be 2 to the 0. This would be 2 to the 1 on day 1. This would be day 2. This would be day 3, day 4. Okay, so on day 3, that would be 8 heads. Okay, and if we want to find on day 10 was the last one, rather than writing this all out and plugging into your calculator, we can reuse the same formula. So we'd have 2 to the 10 heads. Plug that into your calculator to get 1,024 heads. Okay. All right, so if that makes sense, awesome. Okay, if you have any questions, let me know. Haven't gone over this in class yet, so if you have any questions, please let me know. Thanks.